Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the problem numerical number 3, which is based on the RC circuit. Okay, so in this problem, there are some values are given to us, like resistors of the 100 ohm is connected in series with 56 microfarad capacitor. Okay, to the supply, the value of the supply voltage is 230 volt and 50 hertz. So here we need to calculate few things like impedance, current, phase angle, power factor, and last one is voltage across the resistor and the capacitor. Okay, so let's start the solution. Here, the firstly we need to calculate the capacitive reactance. Okay, so which is denoted by x of c. The formula of the x of c is equal to 1 upon omega c or 1 upon 2 pi f c. So from here we can calculate the xc. So let's put the values like 2 pi into frequency is given to us 50 hertz multiplied by capacitance is given to us is 56 microfarad, meaning 56 multiplied by 10 is to power minus 6. Okay, so by calculating the value, I will get the xc is 56.84. Okay, so here we have calculated firstly the value of the capacitive reactance. Okay, next the current drawn from the supply. Okay, next we need to calculate the current drawn from the supply. So next current drawn from the supply. We know the formula for the current is I equal to P divided by Z. Okay. So here the voltage is given to us is 230 volt. Okay. Here we need the value of the impedance, which is the Z. Okay. So here if I write the voltage in term of the polar form, then I will get the 230 at an angle of 0 degree. So in order to calculate the current, I need the value of the impedance. Okay, in the polar form. Okay, so how we will calculate the value of the Z here? We can see that we know that the Z is equal to, in the case of the series RC circuit, that is equal to R minus J of XC. Okay, so the value of the resistance here is given to us, which is 100 ohm. So by putting the value like 100 minus, we have calculated the value of Xc, which is J times negative 56.84. Okay, so this format is known as rectangular form. Okay, so in order to calculate the current, I need the value of the impedance in terms of the polar form. Okay, so we have to convert this rectangular into polar format. So after converting this rectangular in polar, I will get Z is equal to 115 at an angle of minus 29.614 degree. Okay, so now I get the value of the impedance in the required form. So let's put this value here. So 230 at an angle of 0 degree divided by 115 at an angle of minus 29.614 degree. Okay, so after solving this, I will get current which is equal to here 2 at an angle of 29.614 degree, which is leading. Okay, the value of the current. Okay, so this means the current is leading the voltage by 29 degree or 29.614 degree. Okay, so here we know that the phase angle difference between voltage and current is nothing but the power factor. Okay, so here power factor is here power factor is equal to 5, which is 29.614 degree. Okay, so now what parameters we have calculated till now? First one is impedance. We have calculated the impedance. This is our impedance. Secondly, we have calculated the current. This is the current and the phase angle. Okay, or we can say that the power factor we have calculated. Power factor is 5, which is equal to 29.614. So basically, uh, is the phase angle, the phase angle. So power factor will be equal to here power factor is equal to cos of 5. Okay, so power factor cos of 29.614 mean the value of the power factor is equal to 0.869. Okay, yes, we can say that the leading. So we have calculated now power factor and this is the phase angle phi. Okay, phi is the our phase angle. Phase angle meaning the phase angle difference between the voltage and current. Okay. Next, what we need to calculate next? Next, we need to calculate the voltage across resistor and the capacitor. Okay, let's calculate. So the voltage across resistor. We know the formula V of R is equal to I times R, which is equal to. We have calculated the value of current. So check the value of the current. Magnitude is 2. Okay, so the current is equal to 2 multiplied by 100. Value of the resistance is given to us is 100. Okay, so actually the voltage across the resistor is 200 volts. Okay, next voltage across capacitor C. Okay, which is equal to VC. We know that the formula is VC, which is equal to I multiplied by X of C. Okay, so here we have calculated the XC. You can see here the value of the XC is 56.84. So put those value here. Current is 2 multiplied by 56.84, which gives us the value of VC, which is equal to 113.72 volt. Okay, so if I draw the phasor diagram of those values, so if I draw the phasor diagram here, you can see that this is our PR. Okay. So in the case of the resistance, the current is in the same phase with the voltage. The value of the VR is 200 volt and the current which is equal to 2 ampere. Okay. So from here 90-degree apart is VC. Okay. From here 90-degree apart is minus J of VC. So value of this is equal to negative J, which we have calculated here, 113.72 volt. Okay, this is the value of the this. Next, what we need to calculate the resultant, which is the voltage here. The resultant mean total voltage. Value of the total voltage V is equal to 230. Okay, now the phase angle difference is phi, which we have calculated here. The value of the phi is 29.614. Here, phase angle difference is 29.614 degree. Okay, so this is the phasor diagram of our connected load across the 230 volt AC supply. Okay, so this is how we have calculated the given parameters. Okay, so thank you very much. Please like and subscribe our channel.